this is your test review for your test tomorrow. It is on sections 11.1, 11.2, and 11.3. You're starting off by just solving each of these equations. I told you yesterday when you went over this that each of these questions, it's literally like one or like two for each question that's on your actual test. So this is extremely similar to your test, just different numbers. So the first one we have is 8 to the power of 3x plus 2 is equal to 8 to the power of 5x minus 8. Because your bases are the same on both sides of that equal sign, you can cancel them out and just work with your powers. So that means it's going to be 3x plus 2 is equal to 5x minus 8. If it was me, I'd start by moving the 3x over, so I'd subtract it from both sides. This is going to leave us with 2 is equal to 2x minus 8. We move that 8 over by adding it to both sides. We get that 2x is equal to 10. Then divide each side by the 2, and x is 5. If you want to check these, plug the 5 in for the x in both sides of your powers, and then you should get a true statement. In number 2, you have 10 to the power of x minus 3 is equal to 10 to the power of 2x. Again, your bases on both sides are the same, so cancel them out and just work with your powers. So that's x minus 3 is equal to 2x. Move your x over, subtract it from both sides. So that way your x's are by themselves, and you get that x is equal to negative 3. Real simple. For number 3, we have 16 to the power of 4x minus 6 is equal to 2 to the power of x minus 4. Now, with this equation, your two bases on both sides are not the same. So you want to turn them into the same number. The 2 is the smaller number out of the two bases, so turn the 16 into 2 to the power of something. 16 is 2 to the 4th power. So that's 2 to the 4th power times the power of 4x minus 6 is equal to 2 to the power of x minus 4. Now your bases are the same on both sides, so cancel them out and just work with your powers. You have to distribute that 4 into the power on the left side. So you're really working with 16x minus 24 is equal to x minus 4. I'm going to move that x over by subtracting it from both sides. So that leaves us with 15x minus 24 is equal to negative 4. From here, we're going to move the 24 over by adding it to both sides. Let's see. That gives you 15x is equal to 20. We divide each side by the 15. Simplifying, and we get that x is equal to 4 over 3. For number 4, same thing as number 3. You have 8 to the power of 3x is equal to 32 to the power of 2x plus 9. The 8 and the 32 are not the same, so you need to turn them into the same number. 8 is your smaller number. Can you raise 8 to a power to make it 32? No. So you got to turn that 8 into something even smaller. 8 is 2 to the 3rd power. So we're going to write this as 2 cubed to the power, or times the power of 3x. That 32 is 2 to the 5th power. So again, we want our bases to be the same. They are now the same. So we can cancel out those 2's, multiply the 3 times the 3x, that gives you 9x. The 5 times the 2x plus 9 gives you 10x plus 45. Because I have x on both sides, I'm going to move the x over that has the 10 in front of it. So I'm going to subtract it from both sides. And that gives us that negative x is equal to 45. You cannot keep the negative in front of the x, so divide each side by the negative 1, and you get that x is negative 45. For our next section, we are rewriting each of these equations in log form. Remember, with these, your base is going to become your subscript number, your power becomes your answer, and the answer becomes the big number. So we are dropping the base and then switching places with our power and our answer. The power goes to the answer becomes the big number. So we're going to add in the word log. The 6 becomes your subscript number. Then you have 1296 is equal to 4. So log 6 of 1296 is equal to 4. For number 6, we have 2 to the 11th power is equal to 2048. So again, we're going to drop that 2 to become the subscript. The 11 as your power becomes your answer. Your answer becomes the whole number. So that's going to give us log 2 of 2048 is equal to 11. Your next section, you are going from log form to exponential form. So with these, you're going to drop the log. Your base becomes your big number. Your answer, or your big number, becomes your answer. And that answer becomes your power. So we're going counterclockwise here. So this is going to give you 4 to the 6th power is equal to 4096 for number 7. For number 8, you're given log 6 of 1,679,616 is equal to 8. You're going to drop your log. That 6 is going to come up. Your answer becomes your power, and your big number becomes your answer. So 6 to the 8th power is 1,679,616. Our next section, we're just evaluating each of these expressions. For number 9, we have log 3 of 27. So this is asking us 3 to what power is equal to 27. So if we remember from the first part, as long as your base is the same, you can cancel out the bases and you'll just have your powers left over. So 27 is the same thing as 3 to the 3rd power. So if we have 3 to the power of x is equal to 3 to the 3rd power, your 3's cancel, and your log 3 of 27 is just 3. For number 10, we have log 4 of 1024. So this is saying 4 to what power is 1024. If we don't know off the top of our head how many times 4 is raised to a power to get us to that 1024, we can start by just finding the prime factorization or dividing it by 4. 4 goes into 10 twice with 2 left over. 4 goes into 22 5 times with 2 left over. 4 goes into 24 6 times. So now ask yourself, 4 goes into 256 how many times? Well, 4 goes into 25 6 times with 24, so that's 1 left over. 4 goes into 16 4 times. The 64 is 4 times 16. And 16 is 4 times 4. So count up the number of 4s you have. 1, 2, 3, 4, 5. That gives us 4 to the power of x is equal to 4 to the 5th power. Again, our bases are the same, so cancel them out. And it's just 5. For our next section, or for our next question, we have e to the power of ln of 5. So e to the power of your natural log, they cancel each other out, and the only thing you have left is the 5, so the 5 would be your answer. The same is true when your natural log is multiplied by e. They cancel each other out, so like in number 12, you have the natural log times e to the power of 3.02. Your natural log and your e cancel out. The only thing you're left with is that 3.02, so that would be your answer. The next part, we are writing each expression as a single log. For 13, you have log 4 of 8 plus log 4 of 12. We said before that when we are adding two logs, as long as their base is the same, which in this case they are both 4, you can multiply your whole number parts. So this is just going to be log 4 of 8 times 12. That 8 times 12 is 96, so that's log 4 of 96. If these work out either on here or on your test where you can actually find, like for in this case, if it was log 4 of 64, you can actually take log 4 of 64. I don't want you to do that. I just want you to write it in log form. So you could leave it in log form. For 14, you have log 6 of 3 plus log 6 of 8. Once again, your base is the same on both of these. They're both 6. So we are going to multiply your 3 and your 8. So that's going to give us log 6 of 3 times 8 which is log 6 of 24. For the next two questions, if your addition means to multiply, your subtraction is going to mean to divide. So if we have, like for example, 15, log 9 of 27 minus log 9 of 6, again, you have the same base on both of these, which is 9. So you're going to keep the log 9, but you're going to divide the 27 by the 6. 27 divided by 6 is not a whole number. However, you can simplify that fraction by dividing each of those by 3. So the 27 would become a 9 and the 6 would become a 2. So that's just log 9 of 9 over 2. For 16, you have log 8 of 16 minus log 8 of 4. Your base is the same on both of these, so keep the log 8, divide the 16 by 4. 16 divided by 4 is 4, so that's just log 8 of 4. For 17, you have log 2 of x squared plus 3x minus 40 minus log 2 of x minus 5. You have subtraction between these two. The bases are the same, so this is going to become log 2 of x squared plus 3x minus 40 over x minus 5. That numerator you can factor. So you factor it, your factors of negative 40 that add up to be 3 are 5 and 8 if the 5 is negative. So this simplifies to be log 2 of x minus 5 times x plus 8 all over x minus 5. Does anything simplify? Yes, you have the x minus 5 on the top and the bottom, so they cancel. So this is just going to give you log 2 of x plus 8. For this one, because you have more than one term after that log 2 part, you want to keep those parentheses around the x plus 8. If it's not there, then it just means it's saying log 2 of x, then adding 8 to that. So make sure that those parentheses are around both the x and the 8. For number 18, you have log 3 of x plus 2 plus log 3 of x minus 3. You have addition between these two. Your bases are the same, so you're going to do log 3 of x plus 2 times x minus 3. You do not have to multiply this out. You can leave it in the form that you see here. So just as long as you have your log of 3 or log 3 and you have that you're multiplying the two, that's all I need. For 19 and 20, you are rewriting these logs in terms of 2 and or 3. So for number 19, you have log of 12. 12 is 2 times 4, or sorry, 2 times 6. The 6 is 2 times 3. So this is 2 squared times 3. So log of 2 squared times 3. The multiplication can be rewritten as addition. So multiplication means add. So that's going to be log of 2 to the third power plus log of 3. You cannot leave the power on the 2. It goes in front of that log. So that's going to give us 3 times log of 2 plus log of 3. For 20, you have log of 3 to the 5th power. Again, can't leave that power on that 3, so you got to bring it out front. So it's going to be 5 times log of 3. For 21 through 23, you're expanding each of these log expressions. For 21, you have log of 5 x cubed y squared. These are all being multiplied by one another, so you're going to separate them with addition. So this is going to give you log of 5 plus log of x cubed plus log of y squared. Lastly, you cannot leave your power on the x cubed or the y squared. So that has to go in front of each of those logs. So that's going to give you log of 5 plus 3 times log of x plus 2 times log of y. You are all finished with that one, so that is your answer. For 22, you have log of 6x divided by y. Undo your division first, so separate it with subtraction. That's going to give you the log of 6x minus the log of y. Next, you can just separate the 6 and the x with the addition because they are being multiplied by one another. So that's going to give you log of 6 plus log of x minus log of y. The way that you see this, it would literally be the multiplication before the division. So you can leave it this way, but if you'd rather put parentheses around what was in your numerator and put parentheses around the logs of 6 plus the log of x, you can do that too. It does not matter. It means the same exact thing. For 23, you have the log of x plus 1 squared over 3y cubed. Again, separate that division first. That's going to give you the log of x plus 1 squared minus the log of 3y cubed. From here, you can separate the 3 and the y cubed with addition. So it's going to give you log of x plus 1 squared, bless you, minus the log of 3 plus the log of y cubed. Lastly, bring those powers to go in the front, bless you. The 2 goes in the front of that log, and the 3 on the y goes in front of its log. So that's going to give you 2 times log of x plus 1 minus log of 3 plus 3 times log of y. Again, just like with the last one, if you want to put the parentheses around the log of 3 plus the 3 times log of y, you can do that. Do you need them? No. For the last part, you are condensing each of these log expressions. For 24, you have 4 times log of x minus 6 times log of y plus 7 times log of z plus 1/2 times log of w. The 4 we're going to bring over to be the power on the x. The 6 is going to be the power on the y. 7 is going to be the power on z. 1/2 is going to be the power on w. So this is going to give us log of x to the 4th power minus log of y to the 6th power plus log z to the 7th power plus log w to the power of 1/2. The power of 1/2 you have to simplify. You cannot leave a fraction as a power. So the 2, if you remember, is your index. The 1 is your power that's going to stay on it. So this gets rewritten as log x to the power of 4 minus the log of y to the power of 6 plus log of z to the power of 7 plus log of w, the square root of w. Undo your subtraction and your addition. Subtraction means divide, so that's going to give you the log of x to the 4th power over y to the 6th power. Your addition is going to mean to multiply. Now, with these, because all of your addition comes after the subtraction, this whole part here is what's going to go in your denominator. So really, you can just do your x to the 4th power up top, and then it's going to be over all of the y to the 6th power, z to the 7th power, and the square root of w. So it's just going to be the log of x to the 4th power over y to the 6th power, z to the 7th power, square root w. When you're looking at these, from the very beginning, it might be a good idea for you to separate the parts with the subtraction. So like from the very beginning, I would have gone ahead and put parentheses around the 4 log of x, and then the 6 log of y plus 7 log of z plus 1/2 log of w. Just so that way I know anything that's to the right of that subtraction sign is going to end up in the denominator of that fraction when I'm completely done. So like if we look at 25, we have log of x plus log of y minus 3/2 log of z. The part that's separating here with the addition is the first two parts and then the last part. So if you want to work with the first two parts first, you would just get rid of the addition and multiply the x and the y. So that's going to be log of xy. The second part, if you want to work with that separately, you can do that. The power goes onto that z, so that way you have log of z to the power of 3/2. Again, can't leave a power as a fraction. The 2 is going to be your index. The 3 is going to be your power. So that's going to get rewritten as the log of xy minus the log of the square root of z cubed. From here, your subtraction means to divide. So you're going to write your xy up top and the square root of z cubed on the bottom. I do not need you to rationalize your denominators. You can leave it in this form. Okay. Once again, your test tomorrow is on sections 11.1, 11.2, and 11.3. It is 12 questions long. Your review is very, very, very similar to your actual test.